Basically, it's going to be to kind of wrap up the course today, and that way you can use Wednesday as a big old review day. I know we haven't had a whole lot of questions on homework, so and that could very well be because you guys haven't had a chance to get to it yet. And that's fine. So I figure what we'll do Wednesday is just open the whole class for questions on basically anything for the exam. Remember, your last exam is not cumulative. Remember? Yes. It's just the last 3 homework assignments. Hey, Eric, go ahead.
What day is that? 5 o'clock?
Good question.
Wednesday.
It's all Wednesday.
1:15 to something.
3, something, 3:15.
Here.
Wednesday.
Wednesday? Wednesday? Yes, yes. So, in here, right, it's roughly the same time as your class-ish. But you have 2 hours. It will not be a 2-hour exam because you have the in-class and the out-of-class parts just like you always do. But you'll have the whole 2 hours. If you want to sit here for 2 hours and work on it, it's totally fine. I have no problem with that. Yeah, Austin.
Do we have lunch on Monday?
Do you have... No, not at all. Monday, you don't have to come to class at all. I'll have office hours posted for next week soon. I know I'll have at least 8 to 10 on Monday. I know that because I have an exam at 10:15 Monday. I want to have those kids to have office hours if they need to get in. So I'll put more off. I might just put them, it might be helpful. I'll just put them on your class time on Monday. That way you guys, if you already have this class time blocked out and you come in for office hours, you can come then. That might be a good thing to do. Just front load Monday. Thanks for saying that, Austin. I didn't even think about that. So, cool. So I'm looking to make Wednesday just be basically a big old review day. I think that'll be the best thing to do. So we'll finish up central limit theorem today, which you don't realize that we started on Wednesday, but we did with the types. So we'll get back to that. So, cool? How's week 10? Yeah? I know. They do fly. I agree. They fly by. It's kind of staggering how fast they go. So, yeah. I like where we are. I like the pacing where we kind of slide on that last day and kind of just kind of pull back and just be like, okay, questions. Let's talk about the entire back third of the course. Speaking of which, anything from bell curves? Give you guys dreams. Go, Chester, please.
Do you want to just give the problem?
Well, sure.
Assuming a normal distribution, what is the z-score associated with the 90th, 95th, and 99th?
So give me, was it 90th, 95th, and 99th percentile? Okay, great. So the question is, if you're in a standard normal distribution, they want z-scores that correspond to 3 percentiles. Chester, we'll do 1. Once you do 1, you'll have to do all the other stuff, right?
Okay.
Forwards or backwards, first of all? Let me see hands on this one. Hands on this one. Chester has asked me to give her a z-score. And as Corey just pointed out, he said it kind of quiet. I want to make sure you all hear it. It's a number of standard deviations.
95, too.
It's good. So, careful though. Careful. You're correct. You're correct. That within 2 standard deviations is 95%. But she asked for the 95th percentile. What is a percentile again?
5%.
If you're in the 95th percentile. Say that again, Eric?
5th percentile?
No, 5th percentile would be the converse of it, or the inverse of it, I guess. 5% would be, and 95% would be, I'm going like this, I don't know if this makes sense.
It's the amount of values that is bigger than.
Right, think about what percentile means. Percentile is the percentage you're bigger than. It's this is the normal distribution. This is old school stuff. This is from last exam. So that's why it might not be super fresh in your mind. Let's turn the screen off for a sec. We'll turn it back on as well. Actually, let's go over here. So, Gesundheit. Chester, pick one. 90, 95, 99.
90.
90. So, you've got a standard normal distribution. Whoops. Zero's in the middle, plus or minus 1. Now, what Corey said is correct. 95% of the data is within 2 standard deviations. But that's a slightly different question. The question here is, what z-score is the 95th percentile? Let me ask you a simple question. What percentile is that one? Clearly the 50th, because it's bigger than half. So where is the 90th percentile going to be? To the right somewhere, correct? Now the thing is, I don't know where, and that's kind of the question, is to find out how far out do you have to go. So I'm just going to slap it here and call it Z. Is that fair? Now, that's probably not drawn to scale because I don't draw very well. As you can see, that's supposed to be a bell curve. It looks kind of skewed. But I can fix the problem by accepting the fact that it's a standard normal distribution and realizing that I'm going to shade some area here. And what did I just shade? 90% of the data.
Oh, 90.
Well, because Chester asked me to do the 90th percentile. But of course, if it were 95 or 99, you do it the exact same way. All that would happen to your z-score was that it would do what? It would move to the right. 95, 99, move further out. But we'll just do 90. We'll just do 90. So we'll call this 0.9. Now that ties into what Eric said. He said that puts area on the outside. So this area out here would be 0.1, 10%. Whatever's left over to get to 100. So you got 90, 10, 90, 10, 95, 5, 99, 1, whatever. And the reason I put both up there is because I wrote the program to allow you to do either or, left or right. So let's put this back over here. Kick it up. This is where you want it to normal for sure. Chester, making sense so far?
Yeah.
As far as, okay. I think, honestly, it's getting this particular ones like this started and realizing what kind of problem they are is really, once you get that down. Dr. Cam, there we are. Get some light. Sorry.
Yeah, that's kind of what mine looks
I know, except yours didn't autofocus like this one did. Sorry, Big Mike. Okay, so we're into the normal, right?
Backwards.
Definitely. What's the giveaway, Tabitha?
We don't know the Z-score.
Good. And you do know the.
Percentage.
Yes, that's. And again, I made up that name. I called it a backwards problem. When you have the percent, you're looking for the Z. I call it backwards. So yes, it's backwards for sure. And here, this is a nod to Eric's comment about 90-10. You can put either of these in, can't you? You can shade left or shade right, depending on what area you put it. So Beth, your pick, left or right?
Left.
Left it is. I was going to go that way too, because that's the percentile direction. Shading to the left. If we go left, we're going to put in, absolutely, 0.9 as a percentage, as a decimal. There we go. It's going to shade it for us. Here it comes. Lots of area shaded. There she is. And you shade it out to 1.28. 1.28 standard deviations. Now, I want you to, so that's the Z-score right there. That's the Z-score, 1.28 chest. And you see the same thing for 95 and 99. Back to what Corey said. He said 2 standard deviations traps 95% of the day. He's 100% correct. So do you see the difference though?
Yeah.
Right. You take the area that's over here, cut it and put it over here. That bumps it out to 2. So you're correct to say that. It's just that percentile is skewed to one side. It's not symmetric over the average. Fair enough?
Yeah.
Yeah. So both statements correct. Just make sure you know which one's being asked for in percentile. And percentile, I think, is important. It's one of those things that you do hear about. Nursing students going for the TEAS exam, for example. When you take your kid to the doctor, all these things follow essentially normally distributed data distributions. So you want to be able to understand what I have to do to be in the 90th percentile, the 95th percentile, the 80th percentile, things like that. Oh, your son's in the 75th percentile for, head development. Should I be worried? I don't know. Go do some research. Let's do it together. But the other thing is to understand even what that means to get to this point, right? 1.228 standard deviations above average is the cutoff for that 90th. Fair? Great question, Chester. Great question. And please, by all means, use the program because that's what I want you to do for sure. Otherwise, you get your calculus, which is week 10. Let's not even talk about that. Yes, I agree, Cassie. Cool-ish? Anything else, friends? Let's switch back over here. Anything else in here? Please, Beth.
I have 2 different questions. One is in here. I was lost trying to start by myself, and I was wondering if for E1 if you could.
Absolutely. I think there's a twist to E1, or actually E1 through, that I think gives people a little bit of the heebie-jeebies. This is a true story, by the way. My family and I went down to Bishop to do some climbing down the Orange River Gorge and the Buttermilks. And we stayed at the Ramada in there. Jen Splurge was awesome. Instead of camping like dirtbags. It was so nice coming home like a nice warm shower every night. And it snowed like the whole trip. So anyway, we go into the shower, and I'm like, what the? And I'm ducking underneath, and I actually got a tape measure out, and I couldn't believe it was 68 inches from the floor to the top of the shower. I'm 71 inches tall, right? So I'm thinking to myself, I'm like, what, is copper that expensive that they couldn't run a few more inches of copper up to? So I figured, rather than just complain about it, which doesn't do anything, they're not going to fix it, I can turn it loose on you guys and let you analyze it. So what I'm asking is, assuming that guys, and this I Googled these to get the numbers, men's heights average 70 inches, that's 5'10", plus or minus 3, what percentage of men are going to fit comfortably under that shower head? And here's the twist. I defined comfortably fitting under a shower head to have at least 2 inches of room between the top of your head and the shower head. So the shower head's at 68 inches. What is the absolute tallest a guy can be? 66. They have to be 66 inches or shorter to fit. That's my definition of comfortable, 2 inches of wiggle room. So I just made that up, but just a good point. Because you don't want to be exactly 68 inches or you're sitting right there in the water, hitting your head going like this. So, right? So, with me so far, Beth? Does that make sense?
Yes.
So, how do you set it up now that you're there?
Right.
What do you think?
Is it the Z equals X minus
I think eventually, yeah, absolutely. No. I think eventually, yes, you do want to go, you need to use that formula
Right.
because you have to, is this forwards or backwards?
Backwards, right? Because we know that we need the Z-score in order to.
Well, we do need the z-score, but what am I asking you for? Look at the question.
The percentage.
So therefore, it's a forwards problem. Because the only way it's going to be a backwards problem is if I give you a percentage in there. For example, I think E4 is like that. Find the shower head height so that at least 95% of guys fit under, or something like that. Does that make sense? So, but the formula you were quoting right there, Beth, is correct to use the z x minus mu over. Totally. But before you get to that, it might be helpful to see the curve you're on to see which curve that formula is putting you on. Does that make sense? So let's give you a drawing, make sure that you see that, and then I think you can run with it from there and see where you're heading next. And I think this is what you said, to kind of get me started on this. I think this will definitely do it. All right, let's mute this. So we're on the guy's height curve, and it's bell-shaped. What number's in the middle? 70. Well, it will be. We're going to convert it to zero to the zero standard normal curve, Big Mike. Absolutely. And that's what Beth's formula is going to do for us, for sure. But what number's in the center of the guy's height? The average, which is 70 inches. Perfect. Yes, these are perfect. Fair enough? Plus or minus 3 inches. And I like drawing this in because it shows you how ridiculous that shower head is. I just love this. So if this is 73 inches, this is 67 inches. So back to Corey's point, that's 2/3 of data, isn't it, Eric? That's 68% of your data right there. This 68% of guys are not going to fit under that shower head comfortably, are they? So right away, you've alienated 2/3 of guys by putting it at 68 inches. But it gets better, doesn't it? It gets even better than that. Because, so these 68% are alienated. How about these guys over here? Totally alienated, because they're way too tall. So what percent is over here? So this is like 68%. This is like 16, I think, right? If we kind of ish it. So right away, you've alienated 84% of guys. And it's even worse than that, isn't it? Because in order to fit comfortably, you can't be any more than 2 inches, which is 66 inches tall, which is actually 1 inch to the left of this. So basically, there's your cutoff right there. Your job is to find the percentage of guys that are no bigger than 66 inches. Friends, is 65 inches okay? Is 65 inches okay?
Yeah.
Yes. How about 65 and a half?
Yeah.
65 and a quarter?
Yeah.
That's here, actually. 65 and 3/4.
Yes.
Thank you, YouTube world. Yes. So basically, how about these guys over here?
Yeah.
They okay? All these are okay. All of these are okay. Your job, find that. That's your job, is to find that. And to do that, Beth, the formula you quoted is perfect. Take the 66, subtract the 70, -4. Divide by the standard deviation, 3. Was that -1.33333333? That's your z-score. Now, Big Mike, you're over on this curve, and you can get the area. And it's ridiculously small. I think it's like 1 in 10 guys or something like that. And the next question, is it acceptable? That's up to you to decide. I don't think so. I think alienating 90% of the population is kind of silly in a hotel. But, whatever. They're coming at it from a different point of view. They're saying, yes, but copper is $8 a foot. So I can deal with the complaints if it saves you some money in the long run. I mean, this is what's so cool about this. You're looking at one tool that a business person can use to analyze data, right? And if the complaints are outweighed by the cost savings, then by all means, maybe it's just a matter of, if you get the guest that complains a lot about the shower, you give them half off their next stay. And they go, oh, okay, I can live with standing under the shower like this now. Because that was cheaper than buying an extra foot of copper for all the pipes in all the hotels. You see what I'm getting at?
Or lose customers because their shower sucks.
Or, there's the or. So then, what do? You create the probability distribution of the likelihoods of each of these things happening. You see what you're doing? You're beginning to see the connections of this to everything else. Very often, very, very often in the world of statistics, do you have a bell curve problem be solely a bell curve problem? It's usually tied to something else. Just over the weekend, I got CPR certified in Jenny Cruikshank's HHP 212 class. Don't want to brag, got 100% on the final. Don't want to brag, except I just did. So anyway, I was a multiple choice final, which I can't stand, but whatever, it's easy to grade. And I looked at the answers, and the answers didn't look very random to me. Like it was A, B, C, and D, and there were runs of A's and runs of D's. I'm like, there's only 25 questions. It seems like there's a lot of like D, 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 C, D, D, A, B, A, B, 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 B. So I made a 244 final exam problem to analyze that test to see if it was random enough. And then I had them test to see if the runs, if there were too few groupings of runs. And what's so cool about it is I did a little Googling to find out what test I should run. I couldn't find one, so I was like, well, let's just make one up. We'll make up a test based on the assumption that they are random to see how unusual it was if it was an outlier to get the number of runs that I did. So I did a Monte Carlo simulation like you guys did in your last project. Now keep track of the ideas in my head right now. I'm already talking about running a simulation and outliers. So there's 2 ideas from your class already. So then I ran the Excel simulation. Hold down F9. Guess what shape shows up?
Bell.
A bell curve. Boom, idea number 3. So all of a sudden, all this stuff comes together from a test I took for 15 minutes in January. Now granted, I'm diseased. We know that. So my brain goes right to the analysis. But you see how we tied in like half the course in one little problem? That's the way this stuff works, and it's so freaking cool. It's so freaking cool. It doesn't have to be. You can totally ignore it too and just deal with it when you read your research papers. But it's amazing how often this stuff kind of shows up in your worlds. It is week 10. I understand you're not quite as excited about it as I am. That's totally fine. But the fact that you can test data in 2 different ways and a bell curve just pops up, oh, look at that. Just so you know, if you have a 25-question multiple choice exam where there's 4 options for each one, you should have around 19 runs of answers. So in other words, a run would be like AA, B, C. So AA, B, and C, I would call that 3 runs because you have the same A, then the same B, then the same C. That may be BBB, that'd be a run. So basically, anytime a letter changes would be a run. You should have on average about 19. If you have 25 runs, which means every letter is different than every letter next to it, something suspect. That's too random, right? Remember, what does randomness do? What does it clumps? But it can't clump too much. As it turns out, her exam was clumped, but it was clumped very much more than average. I had 16 clumps, on average you should have had 19. So 16 was on the low end of that, but it wasn't down on the 5% unusual. It was about 10% unusual. So there you go. There's your answer. Yeah, a little bit less, but not crazy amounts less. All questions answerable by stuff you learned in this class. Freaking rad. Or you don't care, that's fine too. But the fact is that you can quantify the feeling. I can check my gut. My gut said it didn't look right, and I have a measure to check my gut. And we know, if you've seen my diet, you can understand why my gut would start talking like that. I drink a lot of coffee.
I've seen the stuff on your desk.
Well, that's what I eat, which is on my desk. It's in the keyboard. The number 8 was repeating on my, I was doing an email the other day, and all of a sudden the number 8 just started going, what the hell is that? There's a piece of food stuck in my number 8 keyboard. Oh my gosh. Thank you, YouTube world, for doing that. So, cool, that makes sense.
Yeah.
Decent, okay. Anything else in there that gave you guys grief? Please, Jessa.
I had a question I was asking for the Z-score.
Yes.
Is between, like, 0 and, does it give you the Z-score, but like the percentage? How do you?
Oh, good. Give me the image, if you would, Jessa. What number is this?
0. Or are you?
It's in the text, I'm assuming, right?
Oh, what problem?
What problem number? Just so we have a reference.
15B.
15, what is it?
B.
B as in boy. Okay, there you go. So you got a standard normal, I'm assuming.
Yeah.
Between 0 and?
Doesn't have the Z, but the area is 0.1808.
Excellent. Which way does it go, right or left?
Right.
It goes right, and you don't have the Z. That's what you have to find is the Z. What's this area?
0.1808.
0.1808.
Or is that a percentage?
That's a great question. Is it a percent?
You could make it a percent.
It is. It's 18.08%. Although I like leaving it as a decimal, Chess. I think it's more useful to us as a decimal. First question. If you go to the normal right now, which I'm assuming you're doing, is it forwards or backwards?
Backwards.
How do you know, Corey? Because you're given a percentage. You're given the area. If you're given an area, it's a backwards problem. I think Shelby said it too earlier. You don't have the Z. You're looking for the Z. You have to have the Z or an X, as Beth pointed out, for it to be a forwards problem. But here's the problem. If you go to the normal and you hit backwards, what kind of shape doesn't it allow you to do? Between. It only allows you to do left or right. Anybody know why I didn't include between on there? I actually can't. Not because I'm a bastard, although I can be a bastard, I can. But because I can't put between on. Because if I put between and you put the area of 0.1808, it doesn't know where that area is. If that area is way out here in the left tail, or if it's closer to 0, or if it's where this one is, all those areas are spread out differently because of the curve's not uniform. Does that make sense? So, Tabitha, what's the solution?
Add 50.5 to that?
make it a left or right problem. There's two ways I can think to do this. One way is to ignore this half of the curve and find this area over here and do a backwards problem on that one. So if I ignore this half of the problem, what would this area right here be? Look at this.
0.6.
Wait.
Carry the one. 0.3192. Everybody see how I did that? But make sure, what if I ignore this half of the curve, how much of the curve is right here? Half of it. So 0.5 minus that gives me the area that's here. I didn't draw this very well. This should be much closer to this side, I think. So one way is to figure that area out. But it sounds like the subtraction is freaking you guys out a little bit. Let's go with Tabitha's idea, which I think is much better. Just add this part of the curve on. What did I just add? 0.5, which means now this entire area is 0.6808. And find that z-score, which is the exact same z-score, isn't it? Does that make sense? Yeah. I didn't not give you a between backwards because I'm a jerk. I didn't give you a between backwards because I can't. You'd have to know where the 18.08% is in order to actually get that value. Jess, did you get a z-score for us?
Not yet.
Okay, it's going to be pretty small. I drew it horribly not to scale. It shouldn't be that far out. It should be much closer to the to 0 then, because I'm guessing like 0.47. I was going to say, I was going to 0.5, 0.47. There you go. Yeah. Cool. There you go. So, and again, the reason that works, and Tabitha used this almost as you were thinking about it, you knew the symmetry of the curve. You said put the 0.5 on there, knowing that the curve is 100% and the left side is 0.5. And that's beautiful. That's why I like taking the pace we take through these courses. They're taking each topic 2 days at least to kind of let that idea settle. Jess, that make sense? Excellent, my friends. How do you feel about bell curves? Yeah? Ish. We'll do more today, I promise. More today. Today, I mean, this is the last day we have to like learn new stuff, and there's not much new to learn. Ish. We're getting there. We're getting there. This is the last bit of new-ish stuff to learn, and there's not much new to learn. It's mostly what I like about today is today shows us the distinction between where we are right now and where we're headed in 244. So in other words, how to answer the question like I asked on Friday, how weird is this exam? Is this exam not random enough? And that might seem kind of dumb until you look at something like the Vietnam draft. The first Vietnam draft, statistically, was not random. If you were born later in the year, you had more of a chance of going to active duty than if you were born earlier in the year. And it was just this weird random process that wasn't random enough. They actually tried to make something random and they screwed up, but they didn't test it before they did it. And they adjusted it for, I think I should use the Vietnam War because it's so long ago
Who
now.
was doing that?
What's that?
Who was doing it?
Who do you think?
Exactly.
Congress.
And you
So,
said
I mean,
it's amazing that it was screwed up.
But the problem is that not so much they script it, they don't think to ask people to understand. You'll see it again in 244 with the BP Deepwater Horizon explosion and how much oil came out. With 6 data points, we're going to get a better estimate than the Coast Guard did when that happened. I mean, it's amazing to think about what you can do with very, very little data. So, cool? All right, let's remember where we were last Wednesday. Well, we were here. Let's remember what we were doing last Wednesday. Chef, you get that Z-score back there on that problem? No. Oh my goodness, what's going We'll get it in a second here. You do it backwards? Backwards, good. No, you got it. Well, I mean, that's compared to where I drew it, I drew it way more out.
So you just do
Basically, yeah.
Yeah, before you could enter in that as a friend, I want to know. What? I want the area to left.
That's between. That's a between. That's a left. That's a between. That's a right. These are all fours, so you don't have the areas yet. I'm asking you, yes, my friend. Yes, my friend. So friends, let's take a quick check. The dice are out. Does everybody have the dice with their partners they were working with on Wednesday? He's not here. We can work together. That's okay. You get the points. There's an in-class quiz you get points on. So, did anybody not here Wednesday need to be paired up with somebody? Beth and Sarah, can you guys work together?
I was over there.
You were over there? Okay. So who needs a partner? So Sarah, you were with Austin, is that correct? You were with Chessa. Justine, you were with Austin or no? How about you go with Austin since you guys are right there? Carissa, can we go back with Tiffany maybe? And then maybe, yeah, and then Ashley and Jesse, maybe you guys pair up, is that cool? And then Shelby, you need a partner, how about you go Drew? That's good. Who else needs a partner? Why don't you three work together with a new set of dice? Let's give you,
What color did you have?
actually they're all out, so we'll just go with red. Here you go, Jess.
What am I doing?
You're going to pair up with Beth and I think who else? And Chris. You guys are going to be a triple. You'll work together. Awesome. And let's make sure we all have the correct dice. Okay, real quick. Let's do a quick check. Bella's okay. Who's got the green dice? Green? Okay. Do you have one of each color, light and dark, guys? Okay, you guys are good. You guys are good. Orange. Where are my orange dice? We got to trade up a little bit here.
Wait, I didn't know it was that.
Well, it's okay. I'm going to fix it right now. Orange. Mike, you have the correct. You're good. Who else has orange?